Hello everyone. In this tutoring video, I go over algebraic techniques to simplify limits, which also helps you calculate them exactly, as opposed to calculating the values nearby the limit and approximating the limit. Using the example from the first video, we can notice that although if we try to plug and play using the original form, we'll give you 0 in the denominator. You can simplify the function using factoring, because the numerator and denominator have a common factor, the factor being x minus 2. We can now cancel the common factor out, and you will plug and play x plus 6 over x as x equals 2 means 8 divided by 2 equals 4. So the limit calculated algebraically is 4, just like the limit found by approximating nearby x values. A special type of limit called the Squeeze Theorem can be used for some complicated functions that cannot be simplified algebraically. For example, there is no way to easily simplify this using plain algebra techniques. However, we can notice a special property about the cosine function, in that it has a minimum value of -1 and a maximum value of +1. It will never go beneath or above those specific values. So therefore, we can reasonably assume this is true for cosine of 1 over x, as provided by the function above. Because we're multiplying cosine 1 over x by x squared in the function, the limits get multiplied as well. And because the limit provided is x approaches 0, and the limit of positive and negative x squared at 0 is both 0, we have just proven the limit equals 0 for the function as well, as it is between 0 and 0, so it would have to be 0. This type of limit proof is called the Squeeze Theorem because it involves squeezing the function between 2 points, usually identical, so that the function matches the points and the limit gets proved.